All right, so this is target 9B, transforming graphs by changing a function. Now let's get right into the objectives. You will be able to understand what parts of the function of a parabola represent what changes. You'll be able to identify from a function how a graph changes. And you'll be able to create a graph based on a function. All right, so let's start with our introduction, which should be serving as more of a review than anything. Parabolas are easiest to graph when in vertex form. Okay, so that's vertex form right there. Remember, the vertex is HK. I know that that's a couple units ago, but hopefully you still remember that. Also, if A is greater than 0, the parabola opens up, so your graph would look something like that. If A is less than 0, then the parabola would open down, or something like that. If the absolute value of A, so that means even if A is negative, use the absolute value to make it positive. And if that is less than 1, the graph stretches or widens, so it would look, could look like that, but it'll be wider than that. Or like this if it opens down. And if the absolute value of A is greater than 1, the graph narrows. So that or that. All right. So let's compare the graphs of different quadratic functions. We want to match the function to the graph. So now if we take our equation y equals a times x minus h quantity squared plus k. Notice in all of these, there is no h or no k, which means that our vertex is at 0, 0. And if you look, all of them are at 0, 0. So we're only looking at a here. Now, for all of these, they all open up, which means that all the functions should be positive, and they are. All right. So now this is the only one that has no other numbers in it. This is your parent function. Okay, so any changes to a graph are based off a parent function. All right, so we would say, okay, we've got A. Now this one, A is greater than 1, which means what? Your gut might be telling you that it should be wider, but it should actually be more narrow than this one. And then this one, A is 1/2, which means what? Means it should be wider than this one. So let's go ahead and see if you can figure out which ones go with which. Okay, I'm going to put them in the right spot, see if you guessed correctly. Okay, so there you go. That should be exactly what you picked based on what we just covered. So remember, this is a fraction or a decimal. And if it's less than 1, it's wider than our parent one. This is greater than 1, so it's narrower or skinnier than the parent function. Let's try 2 more. And again, we're going to have our equation, y equals a times x minus h quantity squared plus k. Okay, here we actually have an h and a k. Right? Here, there's no parentheses around or near the x, so which means h equals 0, and then k is right there. So if I'm right, now we have an h and a k, or at least one, for both of these, which means neither one should have a vertex at 0, 0, and neither one does. Okay. Now notice that each one of these lines represents 2, so halfway, this one would be 1. This would be 1, so on and so forth. You get the idea. But we need to find where our vertex is. In this case, we have no h, so it's 0. We have plus 2, and remember, anything to the right of that squared symbol behaves exactly like we would expect it to. So k would be 2, which means that our vertex would be at 0, 2. So which one's at 0, 2? Okay, that would be right on the y-axis, since x is 0. Here, h would actually equal positive 1, because remember, anything to the left of that squared symbol behaves pretty much the opposite of what you would expect. And k equals 2 because it's to the right, and that does exactly what we would expect it to, which means that we should have for this one a vertex of 1, 2. All right, so having that information, see if you can match up the graph to the function. And let's see if you're right. All right, so here, remember we said our vertex was 0, 2. If you look right here, we have a vertex of 0, 2. Here, it should be a positive 1 because it's the opposite of this negative 1 here, or this minus 1. Positive 2, which, sure enough, that matches up. And there was nothing in front, so the graphs have the same shape. It's not wider or more narrow. There's no A. All right, now, we need to describe how the graph of each of the following functions could be obtained from the graph of f of x equals x squared. So we're describing it. We're not writing an equation. We're not doing anything like that. We're just describing what's happening here, what's changing. So, and it's all based on changes from the parent function. So here we have f of x equals negative 2 times x plus 3 quantity squared. Okay, so first things first, when you have these types of problems, figure out what your a, your h, and your k are. Okay, in this case, a is negative 2, because that's that right there. H is negative 3, because remember, it's the opposite of what you would expect it to be. And there's nothing else after it, so k is 0. So what does that mean? Well, let's start with how the graph is shifting. Okay, remember, h is essentially, if you're talking about our vertex, if it's at hk, that's essentially our x and our y. Okay, our graph shifts left because h is negative. So if h is going to be talking about left and right shifts. Okay, if h is positive, if it shifts right. If it's negative, it shifts left. Okay, so because it's negative, we shift left, and we're shifting left 3 because h is negative 3. The graph opens downwards because a is a negative 2, and it's narrower because the absolute value of negative 2 is positive 2, which is greater than 1, which means that it's narrower. Okay? And we didn't have a k, so that didn't change that at all. Here, with our equation f of x equals 1/3 times x minus 4 quantity squared minus 2. Okay, so our a is a positive 1/3. Our h is a positive 4, because again, it's the opposite of what we would expect it to be. And our k is negative 2. All right, so the graph shifts right 4, because remember, h is left and right. If it's positive, it shifts right. If it's negative, it shifts left. So it shifts right 4 and down, because k is going to be up and down. And if k is positive, it shifts up. If it's negative, it shifts down. Since k is negative 2, it shifts down 2. Okay. Graph opens up because a is a positive number, and it's wider because a is 1/3, which is less than 1. All right, so hopefully, again, you get the idea from that. All right, so write an equation for the translated graph. Now, I didn't do any animations with this, so that's fine. The graph of the function y equals negative 3x begins at 0, 0. This tells us our vertex. Okay? We want to write the equation for the function that translates the graph 4 units up and 1 unit to the right. Now remember, okay, again, use this because we want to write an equation, so it's got to be in this form. Okay? Doesn't say anything about the graph getting more narrow or more skinny, so we're going to leave the negative 3 as our a. Okay? H is a shift left or right. If it's positive, it's a shift to the right. If it's negative, it's a shift to the left. Here we're shifting 1 unit to the right, so h equals 1. Okay? And it says we're shifting 4 units up, which means that that's our k value. Because remember, k is up and down, h left and right. So left and right, k up and down. Okay, and since we're shifting up, it's going to be positive, and we're shifting 4 units up, so k equals 4. So we leave the negative 3. Now remember, h is 1 here, which means it has to be negative 1 down here. Okay, because it's to the left, so it does the opposite of what we would expect it to. And then k is a positive 4, so we're adding 4 at the end. So y equals negative 3 times x minus 1 quantity squared plus 4 would be your answer. All right? Final example. Sketch a graph of each function on one graph to display the transformation. So this will hopefully, again, clear things up as far as how a graph is changed by what. So we have y equals x squared. So that's just our parent function. Vertex is at 0, 0. Okay, it looks like that. All right, now what happens with y equals x squared plus 4? So our a didn't change, okay? Our h hasn't changed, so it's still at 0, but our k is now 4. So if I go, my vertex should be at 0, 4, so it should be right there. And it would look like that, okay? And then finally, y equals 4x squared. So same vertex, because again, do I see any h or k with this? No, so which means our vertex is still going to be right there. But the one thing that did change is a is now 4, okay? 4 is greater than 1, which means what? Means that your graph will be more narrow, okay? The bigger the number, the more narrow the graph. The smaller the number, meaning like a graph of 1/2 would be wider than the parent function, but a graph of 1/4 would be even wider than that. All right, so the big idea here, know the formula. Y equals a times x minus h squared plus k. And know how a, h, and k change the graph. Okay, we've gone over a, we've beat that into the ground, so you should understand that. Okay, remember, h shifts it left and right. If h is positive, it shifts it right. If it's negative, it shifts it left. Okay, for k, that's up and down. If it's positive, it's up. Fix that arrow there. If it's negative, it's down. All right, so those are the key things to remember. Once you can know that, you will have no problems with this particular section. All right, that does it. Again, hopefully you took good notes, on the examples, since those are very, very similar to what you'll see on your assessment, on your quizzes, on your tests. If you have any questions, ask.